In lesson 9.7, you will solve quadratic systems. Quadratic systems are systems that include one or more equations of conics. In the first example, we're going to solve this system where we have a line intersecting a parabola. So we're looking for at most 2 points of intersection for a line and a parabola. We can use substitution to solve the system because y is alone in the second equation. So we can substitute in for y in that first equation. So in for y we'll put x squared plus 6x plus 7. And then we'll get this equation in standard form. It's quadratic. So we have x squared, we have 2x plus 6x, that's 8x. And we're adding 5 from the other side, so 7 plus 5 is 12. We have 0 on the right. Okay, now we should try and factor this trinomial into a binomial times a binomial. Factors of x squared go first. Factors of 12 that add to give us 8 are 2 and 6. Make them both positive. So that positive 2x plus positive 6x is positive 8x in the middle, and positive 2 times positive 6 is positive 12. So those are the correct factors, and now we can use the zero product property and set those factors equal to 0 and solve for x. So we find out x is equal to negative 2 or x is equal to negative 6. Okay, so first we'll put negative 2 back into that second equation and solve for y to find a point of intersection. And simplifying, I get 4 minus 12 plus 7, or negative 12 and positive 11, so negative 1, which means we have one point of intersection, negative 2, negative 1. And now we'll look for another point of intersection by putting negative 6 in for x. And simplifying, we get 36 minus 36 plus 7. So that is going to have a value of 7. So another point of intersection is x is negative 6 and y is 7. So 2 points of intersection for this parabola and this line. In example 2, we're going to solve this system, which is a parabola and a circle intersecting. So a parabola and a circle could intersect in at most 4 points. So we're looking for at most 4 points of intersection. And here we can use elimination. I'm going to distribute through that first equation by negative 1 so that I have negative x squared plus y minus 3 is equal to 0. And I'll add it to the second equation, which is x squared plus y squared equals 9. Okay, now adding these two equations together, my x squared terms sum to 0. I have 1y squared and 1y minus 3 on the left and 9 on the right. So getting this equation in standard form, we'll subtract 9 from both sides so that we have a total of negative 12 on the left and 0 on the right. We're ready to try and factor this trinomial. Factors of y squared go first. Factors of 12 that have a difference of 1 are 4 and 3. And we'll make the 4 positive and the 3 negative, so that positive 4y added to negative 3y gives us positive 1y in the middle, and positive 4 times negative 3 is negative 12. So these again are the correct factors. We'll use the zero product property. Set those factors equal to 0 and solve for y. So y could equal negative 4 or y could equal positive 3. So we'll look for our corresponding x values now. So let's use the second equation, and in for y we'll first put negative 4. So x squared and negative 4 squared is 16, plus 16 is equal to 9, x squared. When we subtract 16 from both sides, we get negative 7 on the right. Now when I try to solve for x by taking the square root of both sides, I can't take the square root of a negative in our real number system, so this equation has no solution. So no point of intersection there, but we still have a y value to substitute into that second equation, a y value of 3 this time. So we have x squared plus 3 squared, which is 9, equals 9, and subtracting 9 from both sides, we get x squared equals 0. Here we can take the square root of both sides, and we'll get one solution. X is equal to 0. So we have one point of intersection for this parabola and this circle. When x is 0, y is 3. In example 3, we're going to solve this system. This is an ellipse intersecting a parabola. So again, we're going to find at most 4 points of intersection with an ellipse and a parabola. We can use elimination here. If I choose to distribute through this second equation by negative 4 and then add it to the first equation, I'll have x squared plus 4y squared, this first equation, plus 4x plus 8y equals 8. And in the second equation, I'll have negative 4y squared. I'll have positive 4x. And I'll have negative 8y. On the right-hand side, I'll have negative 20. So now adding these two equations together, I have 1x squared. My y squared term sum to 0. I have 4x plus 4x, that's 8x. And 8y and negative 8y is 0. On the right-hand side, 8 and negative 20 is negative 12. Okay, so getting this equation in standard form, adding 12 to both sides, and getting 0 on the right. Okay, and factoring this trinomial. Factors of x squared are x times x. Factors of 12 that add to give us 8 are 2 and 6. Again, make them both positive. So that positive 2x and positive 6x are positive 8x in the middle, and positive 2 times positive 6 is positive 12. Using the zero product property, set those factors equal to 0 and solve for x. We find out x could equal negative 2 or x could equal negative 6. And now we need the corresponding y values. So let's use the second equation, and in for x in the second equation, let's put negative 2 first. Okay, so we have y squared plus 2y. We have a positive 2 on the left, and we're subtracting 5 from the other side, so that's going to give us negative 3. And now factoring this trinomial and using the zero product property, factors of y squared go first, y times y. Factors of 3 that have a difference of 2 are 3 and 1. We want to make the 3 positive and the 1 negative, so that positive 3y and negative 1y are positive 2y in the middle, and 3 times negative 1 is negative 3. So using that zero product property, I'm going to get y equals negative 3 or y equals 1. So here we're getting 2 points of intersection. When x is negative 2, y could be negative 3, and when x is negative 2, y could be 1. But we still have an x value to substitute in, and let's use that second equation again. So we have y squared minus x, and this time we're putting in negative 6 for x, plus 2y equals 5. Okay, and getting this equation in standard form, y squared plus 2y. We have positive 6 and we're subtracting 5 from the other side, so we get positive 1 on the left and 0 on the right. Okay, and now let's factor this trinomial. Factors of y squared go first. Factors of 1 that add to give us 2 are 1 times 1. Make them both positive, so that 1y plus 1y is 2y in the middle, and positive 1 times positive 1 is positive 1 for a third term. And now when we Use the zero product property. Since those two factors are the same, we only have to set one of them equal to 0 to find out y could equal -1. So another point of intersection happens when x is -6 and y is -1. So 3 points of intersection for this ellipse and parabola. Include with your notes of this video guided practice problems 4 through 8 even on pages 659 and 661 of your textbook.